see the different types of characteristics which is desirable while measuring the instrument any reading while selecting the any instrument. Okay, for example, their limiting error, which is nothing but your maximum error of your any instrument, that should be uh, as much less as much possible. And other error, for example, percentage guaranteed accuracy error, that should be also within a specified range, right? So in today uh, we also discuss different types of parameter. For example, we see the sensitivity of any instrument, precision, what is precisions, and 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 many more. Okay, so today we will start keeping all this parameter in your mind. We will start this our unit number 2, which is nothing but your transducer and measuring of current and voltages. Wait a minute, guys. Okay. Yes. Uh, I hope this screen is visible to you, right? All of you. Now, yes. So, this is our lecture number 1 for module 2, right? So, first of all, what do you mean by transducer? Transducer is nothing but is defined as a device that which convert uh, one form of energy into the other form of energy in electrical electrical instrument which we are using in laboratory. What are the principle they are work on which they are work is the responsible quantity of your deflection is nothing but your current, right? They are work on the uh, current, right? Input quantity is current. At the last, that current is converted into the force, and the force is responsible for the deflection angle of theta. So in that electrical measurement, we are doing the uh, measure the electrical input, right, in the form of scales, different scales. Now in transducer, if you observe, if you want to measure the non-electrical inputs in terms of electrical output, then at that case we are go through this transducer. So a transducer is sometimes it convert one form of mechanical input to the other form, and other form of mechanical input or electrical input. But majority of times we are convert mechanical input to the electrical output. So the common definitions, you can say that the transducer is defined as the device which convert one form of energy into the other form of energy. So this is a basic definitions of this transducer. Transducer that convert physical quantity into the mechanical quantity are known as a mechanical transducer, right? And that transducer that convert physical quantity into the electrical quantities are known as your electrical transducer. Okay, so there are you can also for divide or categorize this transducer into two categories. First is mechanical transducer, another is electrical transducer. In mechanical transducer, what are the your input is either electrical or any mechanical quantity. That it depends, it is not depends on your input side. If you get the output in mechanical terms or physical terms, then you can say that this is your mechanical transducer. But at the same case, if you got the output quantity in terms of electrical terms, then you can say that the transducer which you are using, that is electrical transducer. Okay, for examples, uh, thermocouple that change temperature difference into a small voltage. So here the temperature difference is physical quantity, right? So that convert into the small voltages. So you are getting output as a voltage, so this put in your electrical transducer, right? Or the linear variable differential transformer LVDT used to the measurement of the displacement. So these are the some example which are using under this electrical transducers. Now, the if I see the classification of this transducer classification, you can categorize into different way. Okay, first is active transducer. Now, see, you can classify as active transducer, passive transducer. Active transducer, that transducer which does not require any external source to produce the reading, right? Or to for and the passive transducer, that transducer which required external energy source for its working. So that types of transducer comes under this active and passive. Similar, this analog transducer and digital transducer. Hello. Yes. Uh, Third one is primary and secondary transducer. Primary transducer is nothing but that transducer which are connected to your input side, right? If there are more than one convergence state are there, so you can at that time this primary and secondary transducer are comes into the picture. Okay, so and secondary transducer is responsible to produce your output. Now based on the this transconduction trans based on this your transduction, there are three we can classify this transducer into three categories. First is resistive, second is capacitive, and third is inductive transducer. And one more thing is, if you can also classify this transducer with this help of this transducer and inverse transducer. So you can convert this electrical to physical quantity to electrical quantity, or electrical to physical. So at that time you are comes under this category, inverse transducer. Okay, so today's class we will focus on this resistive transducer, and we in further classes we also see different types of transducer and their categories, on which category they are falls. Okay, so while selecting this, what factor you must take care of that, right? Selection criteria for the transducer. So first of all, depending on parameters which you want to measure, so accordingly you have to select which transducer is best suitable for their uses, right? For example, if you want to measure the displacement, right? If you want to measure the displacement, so there are, you can use the potentiometer. Okay, and if you want to measure the pressure. Okay, so at that time you are go through the strain gauge meter. So there are different depending on your what you are required, so you are using that particular meter uh, according to your applications. So first of all, see what are the on which principle they are working. Accordingly you have to decide your transducer, which transducer is best suitable for your application. Second thing is, this you must be take care of this sensitivity of that meter. I already explained what is the sensitivity. And for the measuring instrument, if I talk about measuring instrument, sensitivity is a supporting characteristics of your uh, any good instrument, right? Sensitivity must be high as much possible. So third is operating range. what is the range of operation of your meter. That's also very important while using any instrument. If you want to measure the voltage up to 100 volt, but for example, if you want to measure the voltage up to 100 volt, but uh, your device is unable to generate that 100 volt in the measurement of this, in terms of this transducer, so that is not useful, right? So that also depending on the scale on which you want to work, and your device must be capable to generate or to measure that amount of voltages or current or any physical or electrical quantity. Okay, accuracy is very important, right? For any devices, any field, this is very important, because if you lose the accuracy, then the whatever you work, that is not worthful, right? So you must be take care of that accuracy by, and how to take care of this accuracy? By the same, you must be select that parameters which is best suitable for your application, right? And similar way, you can eliminate the errors which is associate with your meter or your transducer. And this environmental capabilities, this is also is very important, right? Because at different location or different working conditions, your meters is act differently, right? So it has their own characteristics. First of all, you need to understand what a meter, uh, what are the suitable environment they want, and you have to use accordingly that meter. And this sensitivity and unwanted signal, you must be avoided this unwanted signal. So it leads the disturbance in your system. So this must be take care of that. Okay, and stability for any system, stability is very important. Okay, so your system must be stable for this. So these are the selection criteria of the transducer. You must take care of these points while selecting your any transducer. Now, uh, if I talk about this resistive transducer, uh, so it is a electrical transducer. So I can say that this resistive transducer, if I start this resistive transducer, so this is comes under the electrical transducer. Okay, so the electrical transducer is nothing but the sensing device by which the physical, mechanical, or optical quantity to be measured is transferred directly into the suitable mechanical or electrical mechanical sorry suitable mechanism into the electrical quantity. In electrical quantity means input is input is converted into the, this is your transducer. Okay, so this converted into the electrical quantity, electrical electrical for example, voltages and current. So this is your output in terms of electrical, which is nothing but your voltages and current. This is your transducer. Okay, electrical transducer. So in that scale, your input may be the any physical quantity, or you can say mechanical quantities. Okay, physical quantity or mechanical quantities. So by which you can categorize this electrical transducer. Now, in the same way, transistor must have the this following above characteristics, that is a sensitivity and linearity also important, right? For because for any instrument, if you choose the scale linear, then we do not lose our accuracy, right? So linearity is also one of the supporting characteristics of any instrument, any good instrument. So linearity and this all things which is I discuss in above. Okay. Now now I am, yes, now I'm talking about this resistive transducer, which is the one of the types of this electrical transducer. Okay. So input may be in a mechanical, physical quantity or mechanical quantity, but your output must be your electrical quantity. Okay, so that is called as your electrical transducer. Now, if I talk about resistive transducer, which is resistive resistive transducer, yes, resistive transistor. These are the in resistive transistor, the change in resistance due to the change in some physical phenomena. So at that the transistor which work on this, you can categorize that in this resistor transistor. For example, potentiometer. So this is nothing but here the transistor, those which the change in resistance, which the resistance changes due to the change in some physical phenomena. Okay. And due to that, uh, so the change, for example, the change in value of resistance with the change in length of the conductor using the measure that use for the measurement of uh, this displacement. Okay. So for example, for measuring the displacement, this resistive transistor, potentiometer transistor is a one of the example. So in potentiometer transistor, we are measuring the displacement, right? So as you know that R is equal to rho L by A, rho L by A. Okay. So here, as you know, resistance of any wire is directly proportional to length of that wire, right? So here we will cover this how to change the resistance. First of all, see the definitions of this potentiometer transistor, or you can say working of that. A potentiometer is a resistive types of transistor that converts either linear or angular displacement into the output voltages. Okay, by moving a sliding contact of the surfaces of the resistive element. So, uh, this is the device by which you can measure the voltages, right? Potential uh, between the port, or you can say potential of a cell, you can measure by this potential transducer. So one question is in your mind is, in our laboratory already voltmeters are there, so why we are going to this potentiometer, right? So as you know, as we see the, we already cover the our voltmeter and ammeter, right? We see the internal structure of your voltmeter and ammeter as well. So voltmeter internal structure is a voltmeter resistance is connected in parallel in series with your meter resistance, and that meter resistance is very high, right? But still small amount of current is flowing in that parallel combination of resistance. For example, see here, I already discussed this all things. For voltmeter, right? For voltmeter, what is the internal resistance? We'll already cover. This is your external resistance, or you can say series resistance with your meter resistance, right? So meter resistance, this is your voltmeter. This all voltmeter is connected in parallel. So this is your voltmeter, right? Voltmeter. And this series resistance is very high, very high, but still small amount of current is flowing from this side. So due to that, there is some voltage drop. So you will get the reading when you measure any voltages. So there is a deviation, right? For example, if I want to measure 10 volt, 10 volt, let's say there is a deviation of 1 volt. So either you will get this is deviation, or you can say error, plus minus of 1 volt. So either you will get 9 volt, or you will get 11 volt, right? So this is a possible value uh, you are finding on your reading, scale of reading, okay? So for avoiding this, you are go through this potentiometer. So how this potentiometer is work? See, when the this is a linear, this is a first type, which is a linear displacement, and this is your angular displacement, okay? So depending on your applications, if there is a linear displacement, you want to measure, you can convert that displacement into the this voltage, this output voltages, okay? So for first of all, the basic things is that how to measure the potential with this meter, okay? Then when we are using this transducer, so uh, at that time you can also use that this potentiometer transducer used to measure of your displacement as well, okay? So first of all, see, if there is a input voltages, okay, input voltages is unknown, input voltages is provided, and a resistance wire is connected, okay? And you want to measure how, what are the input voltages for this, or what are the output voltages. If you, if there is a linear displacement, then this port is connected at anywhere from this side. So accordingly, you are able to measure the this output voltages, okay? So you already covered this practicals, or this concept in your 12th examination. So I'm directly using here. Now what is the concept here actually? What happening here, when you use, when you use such a meter, for example, see, when you apply the voltages from here, okay? So all voltages, when you apply the potential from this side, so this is a resistance which is called as your, for example, this is your RT, total resistance of this meter, resistance wire, right? And you want to and this is a port terminal of a linear displacement, okay? So when you displace this port, so this resistance is changing, right? Now see, at initial port, when I use at initial port, so this is an unknown quantity, this is an unknown output, you can't identify what is the input. When you changing this port terminal to this side, then you are able to find out this, okay? One this current means galvanometer is connected in this, okay, experimental setup. So you are identify what current is flowing from this. So at a different location of this port terminal, you can able to find out the current, okay? Once at you goes this last terminal, then the overall voltages, means you are finding the maximum value of voltages, accordingly, right? So with the help of this you can able to find out this sensitivity, right? So what is the sensitivity here? Sensitivity here is nothing but your change in resistance, or change in displacement with your change in resistance with your change in displacement. Okay, when you change this sliding contact or wiper, then this resistance value is also changing, and this is you will get, for example, if I consider this is your for example, if I consider resistance is 2 kilo ohm. Okay, so 2 kilo ohm is nothing but your 2000 ohm, and I'm changing this port terminal with 10 mm. So if I change this port resistance with 10 mm, so you will find out this is nothing but your 200 ohm per mm. Means when you slide this port by 1 mm, okay, by 1 mm you are changing the resistance of 200 mm. So here, change of your this linear displacement, okay, is directly proportional to your resistance. So by this way, by such way, you can able to find out your displacement. Okay, by this way you are able to find out your displacement. Now, see here, this is for the linear displacement. Similar way, for the angular displacement, the same concept is using here. For this angular displacement, let's say this is your zero. This is your for zero. This is your consider this scale is from 0 to 100k. Okay, 100k. So this is your 0 ohm, and this port is for 10 ohm, 10k. This is for 20k. This is for 30k. This is for 50k, and similar way 40k, 60k, 70, 80, 90, and 100k. So these are the different scale of your resistance wire. Okay, so on depending on your displacement, depending on your displacement, your this pointer is move accordingly. Okay, at one position, and this length of all wire you are knowing, right? You know length of this whole wire. So depending on that, now see the relation resistance direct proportional to rho L by A. So this term is making a constant, and we changing only the length of this. So according to that, this is Ohm's law, right? So according to this, when your displacement is happening, so your resistance is also vary. For example, if starting position there is this port is from this side, okay, at starting position. So what at output what you will get? So this point is connected to this side, right, as starting. So this is nothing but your whole input, whatever you are applying the input here, right? When I use that, when I use this, see, when I use first port, okay, so at this is a first case, this is a case first. When this whole when this port is at this point, so what are the current flowing in this circuit is, this is a first port and this is your second port. So current start flowing from this side, and you will get the output, right? And terminate with this second side of this branch. So whole input you will get as your output. So accordingly uh, you are define your displacement, right? Now that displacement is so one question is kept in your mind. So depending on different length, depending on a different length, you are needing different types of potentiometer, right? So here you do the calibration process. Okay, we already see what is that. And for this, different types of uh, for this calibration process, you are using different types of you are capable to measure different types of this different scale of displacement. Okay, wide range of displacement. So generally, this potentiometer are using the scale up to the right, millimeter. Now, when at second case, see, this is a case one. Okay, now at second case, if the potentiometer is comes from this side, okay, for this position, for second position, so what are the output is nothing but your, this is your input supply, right? This is your input supply, this is your input supply is going from this your output, right? So this the circuit is just like that, this side, and this is from this side. Okay, such a way that similar way for this, for case 1, what are the resistances, such that, so by which you are getting different scale of reading. So accordingly you have to calibrate that reading in terms of your displacement. So by such a process you can able to measure the scale of displacement. Now see, these are the samples of your potentiometer. This is your input terminal. Okay, this terminal is, this terminals is nothing but your input terminal, and the last one is your output terminal. This is your input terminal, and this is your output terminal, and this is your wiper, or you can say that this is your sliding contact. This is your wiper or sliding contact, slider, for the for standard volume application, volume control applications. And this above structure is nothing but your control shaft. Okay, control shaft. So by this way you can control the, or by this controlling shaft you can measure the different scale of displacement. Okay, so these are the structure of this your potentiometer. Now what are the advantage of this potentiometer is they are inexpensive. Okay, and this potentiometer accuracy is greater than your voltmeters. Okay, accuracy is greater than your voltmeter, accuracy is greater than voltmeter. Okay, now it is easy to operate, useful for the measurement of large amplitude or displacement, amplitude of displacement. Electrical efficiency is very high, and they are provided sufficient output allowed to control operation. Disadvantage, what are the disadvantage of this potentiometer is when you use the linear potentiometer, a large force is required to move the sliding contact. That is the disadvantages of this potentiometer. and the sliding contact can wear out because of misaligns and generate noise. So these are the two disadvantages of these potentiometers. Okay. Now, okay. Uh, I hope this is clear to you. If I explain more one more times, so simple. If I see the angular potentiometer, what I explained in above is, this is, for example, this is your contact A and this is your contact B, and mid terminal is nothing but your sliding terminal, which is contact C. So there are different scale of reading. Okay, for example, I go 10 to 90 and this is your 100 K, and this all scale in kilo ohm. Okay, so what happening here, there is a this whole resist, this all are the resistance wire. Okay, so here terminal A, B, and mid terminal is C somehow. This is 0 to 100K. So according to use, or according to their applications, this port is vary. Okay, this port is vary depending on your displacement, depending on your displacement, right? So at this also there are different, uh, depending on their length, the your resistance is also vary from 0 to 100K. Okay, at last this is your 100K. So when you sub when you supply the voltages here, okay, when you supply the voltages, if your port is from this side and this negative terminal, sorry, this positive terminal of your port is also connected to this side, and negative terminal is connected to with this. Okay, so here your positive terminal is port is connected to this sliding contact. When your port is connected to this side, then the whole reading you will get. It means uh, you, the whole reading you will get, right, when you connect it to this side. So it means your yes. So this, when you connect to this, then your supply is going from this side to this side, then accordingly you will get your displacement. But when you use at this side, so you will get, when you apply this volt to this side, then you will get this input side voltages, input voltages, right? So accordingly you are just the what are the displacement of your devices. So if I consider one example here, okay, if I consider one example, so you will be more clear about this. First of all, read the question and try to solve it. A linear resistance potentiometer is 50 long, is uniformly wound on the wire of a resistance of 10,000 ohm, or you can say 10 kilo ohm. Okay, 10 kilo ohm. Under the normal condition, the sliding is at the center of the potentiometer. So sliding is the center of your potentiometer. Then determine the linear displacement when the resistance of the potentiometer is measured by Wheatstone bridge for the two cases. For example, case 1 is 3850 ohm and 7560 ohm. And second is, if it is possible to measure the minimum value of 10 ohm resistance, then what are the resol then the resolution of the potentiometer in is. So these two questions are given to you, ask you, uh, try to solve it. What are the data is given to you is, total length of wire is 50 mm. Okay, total length of wire is 50 mm, and this is uniformly wound wire, and wire resistance has a 10 kilo ohm. Okay, so draw the circuit and solve it. Now see, if I if I talk about this is your potential, right, which you apply to the your potentiometer, and the whole resistance is categorized with this whole wire, which has a length of 50 meter. So I can say that this is your xt. Okay, xt is nothing but your total length of your wire. Okay, xt is nothing but your total length of wire, which is nothing but your 50 mm. Okay, 50 mm is given in your question. This is nothing but your length total length of your wire. Now the sliding start at the midpoint, right? So this is given on your question. So sliding start from midpoint, so midpoint, so that's why this is nothing but your 500 ohm, because whole resistance is 1000 10,000 ohm, right? So this is your 5000 ohm, and this is your 5000 ohm. Okay, this whole circuit is your 10,000 ohm, right? So now this is your plus and this is your minus. From this you want to take the your reading, which is electrical output, or you can say potential. So what are the these are the data is provided you in your question, and they ask you first is determine the linear displacement when the resistance of the potentiometer is measured by the Wheatstone bridge. So Wheatstone bridge, we also see the Wheatstone bridge, right? And measured by the Wheatstone bridge with two cases, with this and this. So let take the case one. Uh, Before taking the case one, better to find out the sensitivity here. So what are the sensitivity for this? Sensitivity is nothing but your change in output upon change in input. What are the change in output here? Change in output is nothing but your changing of your this scale of resistance, right? Changing of your scale of resistance, which is nothing but your dr. And what are the change in input? Change in input nothing but your this sliding contact, and sliding contact is in terms of your length, right? So here change in input, I can say that this is your dx. So you can for initial point, or you can say for standard sensitivity of this whole breach is uh, rp, means the potentiometer resistance, divided by xt. Xt is total length of your wire. What is rp? Rp is given to you, right? That is 10,000 ohm. So this is your 10,000 ohm. And what are the xt? Xt is 50 mm. Solid, what are the sensitivity, please solve this. So 5 to the 10, that is 200, right? 200 ohm per mm. These are the sensitivity for this. Now first of all, uh, use this 3850 ohm resistance. So when you use 3850 ohm resistance, okay, when you use that resistance, it means you are slide that okay. So when I use that resistance, so simple change in resistance is nothing but your, for this is your 5000, right? You are using 3 8 50 ohm resistance. So change in resistance is nothing but here. Now see, electrical output is what are the resistance here? 5000. So change in output, change in resistance is nothing but here 5000, 5000, and you are using this 3850 ohm resistance. So what are the changing resistances? 1150 ohm resistance. This that much amount of resistance you are changing. Okay, so what are the dx here? Sensitivity is constant for throughout this problem. Okay, so I can say that this dx or input, see, output is nothing but your sensitivity into change in input, right? Change in input. So output is directly proportional to the change in input. So by this way, you can find out this dx. Dx is nothing but your change in displacement, right? So this is nothing but your dr by s. What are the dr is here? Changing resistance is 1150 divided by sensitivity is 200. When you solve this problem, you will get dx is nothing but yours 5.75. This is your 5.75 mm. So this is displacement, change in displacement. Now second case, this is for first case. For second case, same way, what are the changing resistance? Irrespective of sign, you can use this, find out this changing resistances. What are the bigger quantities? 7560, right, which is given to you, and your output is 5000 ohm. So what are the changing resistance here? Is 2560 ohm. These are the dr. What it means, you're measuring means you're sliding that contact in a both side, right? Then only your output is this 5000 get increases. Okay, so when you above side this 5000 plus something, which is nothing but here is 2560 ohm resistance is added to with this. So changing resistance is 2650, I think, right? And in first case 2560, 2560. In first case you slide in downward side, so your output resistance is 1150 ohm. Okay, so that is this is your 1150 change in. When you decrease from this side to this side, then your equivalent resistance is 3850. And same way, when you add this whole, you will get 7850. 7560, sorry, 7560. Okay, I hope this is clear to you. 7560. So by this way you can measure the displacement from this side. Now solid dx. What is the value of dx here? Is nothing but your dr by s, which is 2560 ohm to 200 ohm per mm, right? When you solve this, you will get 1 2 128 128 by 10, right, mm, which is nothing but your 12.8 mm. Now question number third or second, if it possible to measure a minimum value of 10 ohm resistance, then the resolution of the potentiometer in mm. See, understand this question. You want to measure the minimum value of 10 ohm. What are the minimum value in terms of resolution? Means minimum scale, right? Minimum scale. So, you want to measure the minimum value of this 10 ohm. So you want to find out this resolutions. But we already see the sensitivity of your this bridge is nothing but your 200 ohm per mm. Means one change of 1 mm, you will get 200 mm, right? So but you want to measure 10 ohm resistance. So for measuring 10 ohm resistance, what are the change in length is for changing length, that is dx, right? Is nothing but here, or you can say this is nothing but here uh, resolution of for case 3. Resolution for case 3 is you want to measure 10 ohm resistance, right? And what are the sensitivity is 200 ohm per mm. So when you solve it, you will get 0.05 mm. So resolution of your scale is 0.05 mm. When you put that resolution, then you are able to find out this 10 ohm resistance. Okay, these are the resolutions. Means for example, this is start from this 0, then this term is first scale is 0.05, length of between these two reading is 0.05. And this, if I talk about this is your ohm, that is 0 ohm, so this is your 10 ohm, and the length of this is nothing but your 0.05 mm. Okay, so that's it for today, and this is for your potentiometer. In next class we will already also see the strain gauge and LVDT, that is linear, that is a linear displacement, linear voltage differential transformer. Okay, so these all are different types of transducer we will cover in this unit number 2. And the also the current and CT and PT we also see in this module. Okay, and the in module 3 there are the instrument measuring instrument are there. For example, PMMC and PMMC and moving iron instruments, energy meter, that all comes under the module 3. In module 1 we cover the error analysis. In that we also see the internal structure of voltmeter, ammeter, and use of that both of these two meters. And we also see the error calculations. So that's it for today. For tomorrow we will start, we will see some we will continue these topics. Okay, so if you have any question, please ask. Or if you're not, if you don't have any question, then you can leave now. Those have any question, please ask.